Okay, we are back from a short break. So sorry, we were working on number 20 and I totally airballed it, but I figured out why. And I think that's actually kind of a, I don't know, good mistake to make, I guess. I don't know, because it kind of helps make sense of this. When you're the confusing thing sometimes about these probabilities is sometimes you're looking at it as one event and two different events, and that can be really confusing. And so I've been trying to work through a bunch of these with you to kind of help that. So let's kind of break this down a little bit, and we'll talk about my mistake, and hopefully that will be a good learning experience for everybody. We're going to do one roll, right? It's one roll, but this is the probability of two events, right? A and B. And so to kind of look at this as two separate events of like rolling an even and then rolling a 2, it can be kind of confusing to figure out, well, is it 2 rolls or is it 1 roll, and that's kind of a tricky. So in this case, when we said it's probability of A and B, I originally said that these are independent events, right? The outcome of the first roll won't affect the outcome of the second roll. And typically that's true, right? But this is going to be one roll. And so we kind of have to split this into, I don't know, we have to think of it as one event and 2 events at the same time, which is kind of confusing. So we got to keep in mind it's one roll, not 2 rolls. And so if we're looking at the probability of these 2 events, what we really need to do is we should do this. We're going to consider that it's conditional, that whether we get a 2 or not kind of depends on whether it was even to begin with. And so if you consider these as dependent events, which kind of makes sense because that's what this lesson is about, then the second event would be a conditional probability. So this kind of goes back to that example that I was doing where I was like, okay, let's assume you pull one card, right, from a deck, and let's assume that there was a diamond. Now let's assume that, assuming it was a diamond, or let's figure out, assuming that it was a diamond, what's the probability that it was the ace of diamonds? So that's kind of what's happening here, which is a little bit confusing. So the idea is probability of A is rolling an even and the probability of B is rolling a 2. So what this is kind of saying is like if the probability of rolling an even is 1/2, what's the probability that it was a 2 given that it was even already? So assuming that you already know that we rolled an even number, remember this is the same roll, it's one roll, even though we're kind of considering these as 2 separate events. What's the probability that it was a 2 given that it was even? So there's 3 even numbers to choose from, right? There's 2, 4, and 6, and there's 1, 2 in that group. Okay, so let's kind of fix this here. Again, the probability of A happening was rolling an even. Now there's 6 options for the roll, and there's 3 even numbers. Okay. Now assuming I roll one of those 3 even numbers, the next sample space is 3, because assuming I roll an even, what's the probability of getting a 2, right? But this 3/6, I wrote 1/2. This 3/6 simplifies to 1/2, and then when I multiply, I get 1/6, which kind of makes sense, because if you think about it, what's the probability of rolling a 2 and an even? Well, that's the same as the probability of just rolling a 2, which is 1 out of 6. Okay, so that's kind of the weird thing there, is when you're thinking about conditional probabilities and you're thinking, assuming something already happened, that thing can be, it doesn't have to be like a completely separate roll or a completely separate pick, right? So when we talk about events, sometimes that term can be a little bit ambiguous. We don't know are there actually 2 separate like occurrences, like 2 separate trials of rolling the die, or are we just talking about 2 things that we're looking to happen? And so that word event, it kind of is used in more than one context. So in this case, what we're talking about is one like trial, one roll, but 2 like separate outcomes that we want to have happen. So that's kind of what's going on there. Hopefully that clarifies for you, and sorry about that confusion. Okay, now we want the probability of B assuming A. Well, we actually already found it. So this is the probability of 2 assuming even, right? We already found that. That was right here. That was the second piece of our formula that we used, the probability of assuming it's already even, what's the probability that it's a 2, assuming that it's even? That's 1 over 3. We already used that. And so that's kind of what's going on there. Okay. Let's do the 21, and then 22 and 23 are going to be kind of similar. Okay. So the probability of B is just the probability of rolling a 2. So there's 1, 2 that you can get. There's one way to roll a 2. There's 6 different possibilities. So that's just 1 over 6. Okay, what's the probability of B and A? Now, again, we're going to kind of assume that this is, these are dependent events, right? It's one trial, it's one roll, but these, could be dependent events here. So we want the probability of B times the probability of A assuming B. Okay, sorry, like this. Okay, so what's the probability of B? Well, that was 1/6, right? Okay, so what's the probability that I rolled an even given that I rolled a 2? Sorry, I'm all over the place here. Probability that I rolled an even given that I rolled 2. Well, it's 100%. Like, you have to, if you roll a 2, then for sure you rolled an even, right? So this is just 1. So we multiply that and we get 1/6. Okay? So that's kind of weird. And then the C is what's the probability of A assuming B. So again, we already have that piece. It's right here. That was the second piece we did. The probability of rolling an even number, given that I already rolled a 2, is 100%. There's a 100% chance of that happening. Okay, so that's kind of crazy. This is going to be modeled very similarly to this one. You just have an or there. Okay, so similar kind of idea, but let's assume in these, which we probably should, that these are dependent events, because we're not rolling the die 2 times, we're only rolling it once. Okay. All right, we got a couple more here, and then we are going to, we'll call it. So actually one more, sorry. I know this is long, but I'm hoping that this will actually just help you get through your homework, and you'll be able to do it kind of along with the video and be done pretty much by the time the video is over. So let's take a look at the last one that we're going to look at. So the last problem set is 32 through 34. Okay, I'm going to do 33 with you, and then you can do the other 2. Okay, so it says the table below gives data from a survey on marital status in the United States. So notice that we have all these categories, and we have all these categories here. So age categories, and then we have marriage status in this way. So when we're talking about conditional probability or dependent events, one of the ways we get that is by looking at a subcategory. So when we were talking about the band members and the pep club or whatever it was, this example over here. Oh, band and student council. Remember that assuming that they're in student council is kind of like the first event, right? So we're really only choosing once, but we can kind of consider it as a separate event as kind of narrowing it down. And that's kind of similar to the dice problem we just talked about. Okay, so let's look at 33. So we want to find the probability that a person is married given that the person is 20 to 29. Okay, so the probability, or let's say event A is that they're 20 to 29 years old. Event B is that they're married. Okay, and we want to find the probability of B that they're married, assuming that A has already happened. Now again, this is kind of confusing because there's not 2 different things happening. When we label these events, we're just assuming this outcome is true. So we're only going to pick one time. We're only going to find kind of one probability, but this is not 2 separate trials. It's two separate outcomes that we're looking at specifically. Okay, so probability of B assuming A. So assuming that they are 20 to 29 narrows our focus to this group right here, right? So 20 to 29 is all of these people plus all of these people. So that's kind of the first event, is narrowing it down from all the people in the table to a smaller subset. Okay, so we need to add those 2 numbers together to figure out how many that we actually have in our sample space. So we got 18,142 plus 19,401. Okay, so it looks like that's going to be our sample space. Okay, and then we want to find the probability that they're married. So we need to look at the married column, and we need to add up these two numbers. So this is, if we add these two numbers up, these two numbers up, that's all the different ways that we can get a married person from this age group. Okay, so we're going to do 4,407 plus 9,913. Okay, so 14,320. Okay, and then we'll divide those numbers. This is probably not going to come out as a super nice fraction, so let's put it in decimal form. Okay, so it looks like it's about 0.38. Let's go 1, or 38.1% chance of that happening. Okay, so it's a conditional probability. There's that answer again. It's a conditional probability, but the idea is the first event is like narrowing it down to a small subset, and that's how it changes the sample space. So it's kind of like those Venn diagram questions. Okay, I hope that helped. I know there's a lot there, but if you're having a hard time, then that is a lot of help. If you maybe are doing it on your own and you feel pretty confident, maybe you didn't have to watch that whole thing. But either way, we got through it. So thanks for hanging in there with me. Sorry about that glitch, and good luck with your homework. This one should be pretty easy now.